Hi, in this video we are going to discuss um, Python implementation of filters. Basically, Python implementation of uh, how do we plot HZ poles and zeros and the magnitude response and phase response, etc. So I'm going to introduce a new library here called SymPy. It's a it's a Python library, and the good thing about this library is that it can do symbolic manipulation. So you can directly use HZ and write your expressions uh, um, as like your HZ will be directly uh, um, um, what do you say, a function of Z, right? Where Z is a symbol. Okay, so let me introduce this and in practice. So I will import. Okay, I imported SymPy and I imported symbols, and Z is a symbol. It's a variable now. Z, algebraic symbol. Now this is how do we plot magnitude and phase response using this. So I will first of all I need to evaluate my h of z. H of z is an expression written with this symbol. I can give you an example. Like I can write uh, hz is equal to, let's say, z plus 1 divided by z minus 1, just any arbitrary expression, and I can now evaluate this hz at various omegas. Omega can be is a numpy array, um, and I used lambdify function. Okay, you can read the details. Uh, okay, now I want to plot hz, basically the magnitude and the phase plots. So what I do is, first of all, I evaluate all the hz at all the omegas. These are the omegas which I give minus pi to plus pi, 1,000 uh, discrete points, and I compute the h. Now I get the magnitude and phase from this numpy array, and I just plot them, right? So this is an example. Like hz was, this is an all-pass filter, right? Uh, and I have plotted this for, so basically a COM filter, which is, no, it's not an all-pass filter, it's a COM filter. Yes, uh, it is a COM filter which has L as 6, and so this is how the filter looks like, and this is how the phase response looks like. Okay, and I can also write functions to plot poles and zeros on the z plane. So what I do is, first of all, I get my hz, I decompose into numerator and denominator. For the zeros, the numerator is an expression of z, right? Um, um, it's a polynomial expression, but I need to compute the roots, right? So for computing the roots, I will use this function sympy.solve. This will compute the roots, and I save in this list zeros. And similarly, if I find the roots of a denominator, they form my poles. Now, plot poles and zeros. These poles and zeros can be passed to this function, which plots the poles and zeros. So this one is basically of the similar form as you have seen in the previous Python, um, the Python exercise in the previous week. Okay, and so you take any arbitrary h of z, any expression of z, and compute the poles and zeros and plot them like this. So it's a very useful utility in Python called SymPy, which does everything. Thank you very much.